my name is Dan Murphy and I write code for the FT. So I saw there was a few other coders in the room when we started this morning, so I'm going to be talking a little about some of the practices and code that we write, and also about some of our experiences of both using a triple store and also a graph database to give you kind of two different sides of the story. And the story really is one about a project which wasn't doing particularly well and that was at risk of failure. But before I get on to the project itself, I just want to share with you a few things about the Financial Times. So the Financial Times was first published in 1888, except it wasn't called the Financial Times then. It was called the London Financial Guide. A little bit later, within a few months, it actually changed its name to the Financial Times in February that year, so in about a month after it started being published. So the Financial Times has already changed within the first month of it being produced. And it carried on publishing newspaper print, and then around 2008 it introduced a feature which allowed subscribers to read premium content on the website. It was one of the early introducers of the kind of paywall technology. And within a few years, what we noticed at the Financial Times was the graph of print distribution was kind of going down this way, and the graph of online subscribers was going up in the other direction. So what we saw was that people were changing the way that they were consuming the Financial Times, moving from a physical paper-based medium to a digital medium, and probably fueled by things like the HTML5 app, which was released around 2011, we saw actually a crossover, and today we make more revenue from our online subscriptions than we do from our physical newspaper, which might come as a bit of a surprise for you because everyone thinks of this big broadsheet which is pink. Website is still pink, so we've kept some things. In fact, the pink shade changes every now and again. So this is the sort of the current website, and as you can imagine, being no longer based on physical paper, it allows you to do more things. So we can have videos and podcasts and wonderful interactive graphics on this site as well. This site, though, is fastly approaching its retirement. A little later this year, we will be continuing our process of onboarding new users onto the new website. And one of the reasons for that is that this website was built as a monolith application. And that didn't serve us particularly well. It was right at the time, and it was a way to do things at the time because microservices hadn't taken off at that point. But what it also meant was that the data and the presentation were all kind of mashed together. So it meant that if we wanted to reuse the data in other ways, we actually had to change some of the basic foundations of the website, and that caused difficulties because you might break the website. So there was this problem of what we always think of in computing, which is kind of separating content and presentation away from each other, which needed to happen. So, a little bit, I can't press that, sorry. So just over 18 months ago, a band of developers got together and they decided they'd go on this adventure to try and create this new version of our content store. And this content store was going to take an API first principle. So all of the content was going to be available through APIs and through some kind of data feed, and we could then reuse the content in various different things, one of them being a new website, possibly in other things like mobile devices, and also being able to provide that data to third parties and to business partners purely as data feeds. So they decided they were going to build this, and we wanted to be able to provide a rich way of linking our stories and other information that we knew about. So we write about companies in the financial markets. So what we wanted to do was be able to talk about organizations and to be able to link those with the stories that we were writing. And so the path that we decided to take at that time was to head off in the land of semantic linked data. And that was just about 18 months ago. For my own part, I wasn't quite there, and in fact, I was looking quite different then as well. So 18 months ago or so, I was just waiting for my second son to be born, and I was a freelance developer, and at the same time, I was also working as a volunteer counsellor at a domestic violence refuge. And one of the things working as a counsellor we notice is that change is really difficult. People really don't like change, and I think Chris has talked about this, about the barriers to change that happen inside organisations. And so what we have to do is kind of help people through that change process. And 18 months ago, 18 months ago, I was working as a counsellor, and then I decided, after taking a bit of a break, that I needed to find a new job. So I found a new job, and it was at the Financial Times. And it looked really interesting because it was a greenfield development, building this new content platform. And this new platform was going to be using APIs, which is something I've been working on for a number of years, and providing that out to for other uses. I arrived in around November last year, and within a couple of days of getting there, it turned out that the project was in an unstable state. It had come to a point whereby it was actually not going to deliver. So we had been working on this project for about 18 months or so, and really it wasn't going very well. And to be perfectly honest, the senior management were quite concerned about it, understandably, because it was taking a long time and it was holding up delivery of other things. And so we kind of got to this point where we had to change. Now, exactly what had gone wrong is kind of a bit difficult to figure out. So I've done a little bit of investigations, but I don't think I would quite be up to Benedict's standards when it comes to deciding exactly what went wrong. Because we did have some technological failures. Technology is not perfect and it breaks, but then we were using software which was new versions and things like that, so we did have some technology problems. But broken technology wasn't really the sole cause of our difficulty that we had. It was also to do with people and culture. So again, if you remember back to Chris's picture of the modeler, the process that we had around modelling was challenging, and in fact the process was slightly taken away from the core development team. And so that disjoint between the people who were writing the code and the people who were doing the modelling meant that it didn't work very smoothly, because you ended up with effectively a kind of waterfall process, which is not very good. The other things about the culture was that actually the choice of technology was kind of imposed on the team who were using it. And if there's one way to really annoy a bunch of developers, is tell them they must use a certain set of technology. Because what they want to do is actually make choices themselves. Because if you don't let them make choices, then as soon as the problems start happening, then they're going to kind of look, this technology doesn't work, it breaks, kind of thing. So technology did cause us some problems, and culture certainly caused some problems. The exact details of that is possibly quite irrelevant, because what it meant was that this journey we were heading on towards the semantic linked data platform was kind of like trying to carry all of this stuff in your backpack. It was just slowing us down. So it looked all very comfortable. We had these lovely models that we were building, and we had all this great equipment with us, but the net effect was it was kind of dragging us along. So there we were trying to get off to finish this project, and all this stuff that we were carrying with us was slowing us down and stopping us delivering. But we did have an advantage. We hadn't built a monolith. So what we had built was a set of components of microservices, and these microservices were fairly pluggable. So I'm assuming that this audience understands microservices. A few nods. People here using microservices? Good, excellent. So for those people who didn't put their hands up, there's a number of things you might want to look at, which are things like 12-factor apps, which kind of explain how to build good microservices. But the idea is that basically we can take one of these blocks and replace it with something else that has the same kind of interface, and the internal running works the same, and actually these will work independently. So what that meant we could do was to try and change things. In software engineering, we often talk about changing just one thing. And what microservices allow you to do is actually to chuck away a lot more and to try changing more things at a time. So rather than just simply changing from a linked data platform to a different type of platform, we could also change things like the programming language that we're using as well. So we did what the FT call a quick start in order to kind of get stuck into this bit of coding. And the quick start is basically a spike in XP terms. So we kind of locked ourselves away in a room for a week. We were allowed out to go to the toilet and to have lunch and things, but basically we switched off, cancelled all meetings, and we spent a week in the room coding. And what we decided to do was to really examine what we were using in our technology stack. We had started off with Java and RDF, and we wondered what else we might be able to do. Just wondering if this was going to build. Let's try that. Oh, sorry. So we also then decided what we wanted to do was to run also with a graph database, and we picked Neo4J as our graph database. And I think it's fair to say one of our lead architects is a bit of a Go fanatic. So we decided we would try Go as well. And it was interesting because none of us had coded in Go apart from our fanatical friend. So he came along to help us with some coding. Because we wanted to try out whether it was Java that was causing a problem. Was it the RDF triple store that was causing the problem? Or what was it, and what can we change in order to figure things out? So we tried this different combinations of technologies, and what we found, a nice sweet spot of Go and Neo4J. We tried things like Java with Neo4J, but we hit a problem which I think is common for lots of people who have looked at Neo4J, is that there's actually a lot of choices of how you can talk to that as a database. You've got things like the JDBC driver, you've got the Spring Data components, you can talk to it through the RESTful interfaces, and we found various different challenges around there, and actually we found the Java one still was a bit slower when we were talking Java to Neo4J. So we picked Go and Neo4J as a good combination. And in fact, what we actually ended up with is a particular library which is called Neoism. So if you are investigating the combination of Go and Neo4J, I'd strongly recommend you look at that particular library, because that library actually allows you to do things really quickly and really easily. And I'll show you a bit of code in a moment. And I would guess that even those who have never seen a line of Go could actually figure out what's going on in it. So it's a great combination of technologies. The other things that we kind of learnt along the way, and I think James touched on this a little bit, is the ability to refactor your designs. So we don't have the sole source of information. As Chris was talking about before, we augment data from different sources. So we have data which comes in from a system we have internally called TME. Not entirely sure what that acronym stands for. And also we have data about legal entity identifiers, which is about organisations which trade, and we don't own that data. And we also have data coming in from a third party called FactSet, which kind of builds up our picture of what we know about organisations and people, so that when we write articles we can link them to organisations and people, so we can link up our articles together, so you can more easily discover the different types of content that's around. So one of the things we had to do was figure out how we were going to do this, and our first approach was pretty naive. We simply put some extra properties on our nodes, and it kind of works, but it looks a bit messy, doesn't it? It kind of starts polluting things. So you end up with decorating data into the root of your node about different types of identifiers. Obviously we have our own UUID, which is not just a simple integer, which Chris will probably be pleased to hear. So our next approach then was to say, well, okay, let's gather those together into this collection called identifiers, because then as we augment with different data sources, so if we want to pull in identifiers from Wikipedia or DBpedia or other financial data sets, then we can include them this way. Unfortunately, it doesn't work. We were to discover. And the reason it doesn't work is that you would hope that you might be able to search for an organisation which has an identifier of type TME with a value of XYZ. But unfortunately, in the graph database, you can't match on those subset of things in this particular thing. So we couldn't take this approach. So the approach we ended up with instead was to add some extra nodes. So anyone who's been through this kind of process will probably understand where you get to. And the great thing about graph databases is that they're schemaless and they can be refactored really easily and quickly. So actually going through this process was very painless for us. And we obviously ended up with 2 new nodes of type of identifiers, and those identifiers contain a particular authority and the value of that identifier, and we can link them together. And that way we can concord our data from as many different sources as we want, which means that we have one description of an organisation called Apple, and we can link it together with other identifiers from different systems. So if we wanted to put information in from DBpedia about Apple, then we can link in their identifier as well very easily. So we spent quite a bit of time sort of practicing our skills and honing our techniques and coming up with some approaches to things. And so now this is the bit where you get to see some code. What we came up with, as you can see, is some fairly simple structures that we were going to store. So this is Go code, and it happens to be from one of our brand's APIs, and unless there's something sensitive in it, like someone's put keys in by accident, all of our code is available on GitHub. And what you can see in there is that we have a couple of structures. So all of the things that we store in our graph database are things. And we have a common way of describing those things, which, as you would expect, is an identifier, some kind of URL, and then a collection of other properties about it, like the things that it is, and a pref label, which is kind of like a name, really. So for a brand, we have a thing which has then got some additional properties on it. And this is quite easy kind of stuff that you can sit around a whiteboard and do very easily. And then this is the actual bit of code which does the query for us. So I hope it's fairly easy to understand. And let's see if this pointer will work. If I can figure out the button. There we go, without blinding anyone. So what we're doing here is a simple read operation on our public API, and it's a get by UUID. And what we do is we look for a brand, in this particular case, which matches our UUID. Now we have a parent-child relationship which can go on between brands, which is where these optional matches come on. And then what we do is we simply build up the return structure that we wanted to send back through the actual API. So here we're returning back a fairly static structure. And there's a question about schemaless versus schema, and how do you stop stuff getting into your schemaless database that you don't want in there, basically. And the answer is, well, you don't enforce it in the schema, but you can enforce that type of stuff through code. So if you have nice microservices which have got well-defined interfaces, you effectively are putting a schema over a schemaless system. So we can be sure that we're putting the right data in. There's a couple of extra little functions you might notice in there. Basically, we took this approach because the Neoism offers two ways of querying a database. You can build up these kind of complex structures here, or you can return back a node in your database. What we found was that the way that it worked was that if you're not careful, you end up making multiple calls to the database to get out simple answers. And obviously when you're trying to build high performance APIs, what you don't want to do is to make unnecessary calls to the back end. So this is a function in Neo4J which takes out a set of labels on a node and puts it out as an array of strings. And that stops us having to actually go to a separate API to say, tell me the node types that this belongs to. So we saved 1, 2, 3 calls in there. So we do one rather than that. We did have some challenges along the way. We did have some issues. As I said to begin with, tech isn't perfect. We found a bug, which, considering we were only using Neo4J for a few months, I thought was quite impressive that we managed to find a bug. Thankfully, with the help of Jesus, we've got that bug resolved quite quickly, so that was good to see. And as I said, we tried things like the JDBC driver and found some limitations in that driver that we didn't like. And one of the other things we didn't like, which I hope will come out at some point soon, is things like date and time, because we all are interested in storing things like dates and times and be able to sort by dates and times. It's not a native element inside Neo4J at the moment, but hopefully that will be there at some point. There is still, I think, one challenge with linked data and connected data, because we're busy talking about linking all of our data together, because that's how we get value out of it. And then at the same time, the architectural patterns used to build our systems are microservices. And the idea with a microservice is that it can kind of fail or not fail and work without affecting the rest of the system. So here I have a made-up example. Unfortunately, you can't read the labels as well as like, but you have a chap called W Coyote who has a plan A in which the intended victim is a roadrunner, and he's going to use the anvil in order to carry out his plan. So we've had Batman, and now we've got another cartoon coming into this. So how are you going to deal with that in the world of microservices? Because obviously these entities, if they exist or don't exist, then you can't really link them together properly. So we came up with an approach, and I'm not convinced it's necessarily the most perfect approach, so if there's suggestions in here or people have got thoughts on it, I'll be very interested to hear them. And what we came up with was the idea of, very simply, kind of putting boxes around things that are owned. So our character service is responsible for writing and owning our characters, unsurprisingly. There's a plan service which operates on plans, and there's a trap component service which operates for trap components. But that still leaves a couple of things, which is how do you get the whole picture? So you have a doomed event API, because you know it's not going to work. Mm-hmm. And that then is the one that's able to understand the whole graph, whereas the trap component service really doesn't know much about things other than what you'd use in a trap. So you can kind of arrange your microservices in a way that you have areas of responsibility for them. There's a proper term from that which I can't remember. But that still leaves you these links between them, doesn't it? So I might have something that can write a character, but how do I link a character to a plan? So again, we decided an approach to do this, and it's quite simple, which is who owns a relationship. So if you see the relationship between the coyote and the plan, he has a plan. So therefore, we would decide in this situation that the coyote is responsible for linking to the plan. However, the plan has an intended victim. So in this case, kind of relationship in this model is going this direction. And so when we write plans, we put in links to potential victims or intended victims. However, all we're doing is we're actually making a stub of that potential victim, a thing. And then later on, at some point, or even beforehand, the RRunner entity can be generated by the character service. And so when the plan comes along, it just either creates a link to a skeleton Roadrunner or links to an existing Roadrunner. Obviously, then you've then got the question of what happens if he's actually one day successful and kills the Roadrunner, and you want to delete it from your system. Do you want to maintain the fact that there was an intended victim? So you might just put a death on the Roadrunner, or you might decide that what you want to do is actually delete the character from your database. In which case, what we decided we would do was we would remove all the properties that made it anything but a thing. And then look at any relationships around it. And if nobody is pointing to my thing, then it's safe to delete. But if something's pointing to my thing, so if there is a plan pointing to the Roadrunner, we remove things that make it a character or a bird, and just leave a stub of a thing. So the plan still has a relationship to something, we just can't tell exactly what that relationship is to. And there's tools which will help you with this, and I think if I look at some of the challenges around RDF and some of the features that you see in graph databases, being able to visualize this stuff with built-in graph databases I think is incredibly valuable. And I think that if we want to see more people adopting actual triple stores, I think one of the things they could possibly start doing more of is actually providing these visualization tools, because it makes life so much easier if you can drag and move around these things and these links, because we are visual people. Personally, if someone gives me a big blob of XML, or whether it's nicely formed turtle or whatever, I kind of glaze over once I get to line about 50. And so instead, with this, you can visualize hundreds of relationships and start dragging them around, which is where it gets quite powerful. So all of that has meant that now, on the new website, which some people are already starting to use, we can surface all the same kind of data that we did before through using APIs. And again, it's not typically clear, but what you can see is that there's, on the right-hand rail of these things, it gives us the ability to link in lots of extra information. And also, it allows us to do things like this, which is a bit more personalization of it. So there is a part of the new website called MyFT where you can follow topics. And so this is where we start linking our data and content together. So whenever we write a story about, I think that says news, there's Brexit or something in there as well as Apple. So whenever we write a story about one of those organizations or people or something like that, then it's very easy for someone to discover it. So it's kind of a bit like, you follow a person on Facebook or Twitter or whatever, but this is about following particular types of information. And being API means that we can also fairly easily adapt it. In fact, if you kind of were one of the early users of the Next site, you will notice that it's constantly changing. And it's constantly changing because it's all microservices based, or the web app is microservices based and is being driven by APIs behind, which allows us to switch and change things very easily and rapidly, rather than building this monolith thing. So we took a really brave decision and kind of canned about 18 months of work back well, we actually decided in December, and we spent about 3 months rewriting it. So if you think we'd had a project which had failed to deliver over 18 months, we threw away the actual implementation of it. We still reused a lot of models, but we rewrote it in 3 months. I think that's a pretty impressive feat to achieve, and it's now turned the project around. It's delivering value to the business, and it's helping us serve up the new value, the new website as well. So as I said, I'm between you and lunch, so I should leave it like that. But if you have any questions, I'm very happy to take some.
Please.
I'm just curious. You said at some point that you weren't able to search for a component of the ID, and you had to separate it out into separate nodes.
Yes.
Why was that? Why couldn't you search for a specific part of the ID? Was that a technological limitation, or was there another reason?
Yeah, that was basically it. It's the way that that you can. So, if I remember correctly, and this was a little while ago when we tried it out, was that when you're doing a match on an embedded, effectively in a field with embedded values, you can only match on the total thing. So if we searched for an entity which had both of those fields, it would be fine. It would find a match. But we couldn't do, or at least what we couldn't figure out how to do, was to match it on just a small subset. You can do it in other systems, so it was just an implementation restriction. But actually, I think, long-term wise, we made the right decision anyway, because actually it's more powerful if we have different identifiers, and it allows you to concordance a lot better.
Even if you sub-index with Elasticsearch on the keys?
Yeah, so we didn't use Elasticsearch.
Okay, cool. Anyways, I have two different questions.
Sure.
So, first of all, you said there was like that query forms somewhat of a schema that guarantees the things that goes into your database, like follows a particular structure. Was there anything else that had to enforce that query onto the data, or that query alone was? Was there any more? Yeah.
Yeah. So there's two parts of that. If I go back.
So that was the second part.
If I go back to how it works, is that basically this is the definition of the public interface.
Yeah.
So when the messages go in and out, or actually just out in this case, because the public brand read is a read-only API, that structure defines the structure of the JSON message that's sent back out. We do the same with the writers, so we have a JSON message defined in code, which when we pass, so the writer, when we want to write to the database, the inbound JSON message has to fit to that structure, or it won't deserialize properly, so it gets chucked out,
okay.
And then goes back onto the queue. So we have a message-driven queue, message-based system for putting them in. So we know that by the time, if you imagine that this is a writer, that the structure comes into here, it's already well formed.
So there's no relational structure on like how things can relate with each other. The schematic exists on the thing or the entity, on the properties that it can have, basically.
Yeah. So if you look here, for example, we've got parents and childs. Okay, and all we'd say about parent and child is a thing. So we can define a relationship between entities, and we just describe them as a thing, and then allow the other thing that the other API that controls the other entity to define how that entity looks.
Okay, cool. Understood. Yeah. The second question is a little bit bigger. So, microservices, like you said, they're all separated services, and they work like individually. They produce like information individually, and they work together with other services. But why does the data have to be separated into each of the microservices? Why can't the data sit on another layer in which they're all aggregated in some form of a distributed database, where the microservices only operate as a business logic layer on top of the data, and therefore the data is always all connected? You don't have a problem of how do you connect the data between microservices.
So if I understand you correctly, I think what you're
Take the data out of the microservices and sit on a layer which is used by all of the microservices.
Yes, correct. In very short term. So if I go onto this, maybe I didn't quite explain it correctly. So this is the separation of concerns for the microservices only. They all of these entities sit inside the same, in this particular case, sit inside the same instance of Neo4J.
Okay.
Does that answer the question?
Okay.
So in other words, if you were to query Neo4J as a whole, what you would end up with is this, where these are different types of nodes, if you look at it raw, in its raw form. But what this allows you to do is to assign the responsibility for maintaining an entity to individual microservices. But the actual data is still all persisted in one big system. Mm-hmm. And what my slight concern is, obviously, that means that system has to be highly available, highly scalable, and blah, 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 blah.
Or at least ACID.
Yeah, well, yeah. But I mean, basically, the system doesn't work if one database component fails. So, in that sense, the microservice is affected by the operation of the database. So the whole of this will stop working if we were to lose our entire Neo4j cluster.
Okay.
Which we hope we wouldn't do, but that's kind of the bit which doesn't quite fit with microservices in my mind.
It's not highly available in the sense?
Or in the sense that
there's no replication.
If the Neo4j breaks, then all of these break rather than one.
So therefore, separation.
So we could, but then if you start separating instances of, so if you wrote these to different databases, then to do the connections would be a bit of a pig.
Yeah, you have a sharding problem.
Yeah.
But if you have a replication of like 10 different databases where microservices can basically talk to any of those 10, then
yes.
it don't happen.
Yeah. So if you've got a highly available cluster, or as you say, replica set in Mongo terms, then you can write to each of those things.
And is that how Financial Times do it now?
Well, we have a cluster which is effectively a highly available Neo4j system. So we kind of do it through clustering. But I think the point I'm trying to make is that if you look at the kind of like the textbook case for microservices, then each microservices has a different instance of a database associated with it. So you might have a user database system, and that will be very distinct from your order database system. And so what you end up doing is having to query across the microservices, which is obviously less performant, in order to combine those data. And when we're talking about graph and link data, the value is actually in it being linked together, which is where there's a bit of a disjoint between microservices, in which everything's separated, and linked data in which everything comes together.
Okay.
Great. That's very good. Thank you. Any other questions? Yeah?
Who does the modeling you have in this slide? Do you have curators or the journalists do this work?
Where is
do you
it?
do machine learning?
So at the very back of the room is Guy. He's looking around pretending he doesn't exist. So Guy is our head of information architecture. I think that's the correct title, isn't it? Head of information architecture. And so we work with him as part of the financial services bit of work. And he also works with the journalists and with other parts of the organisation to ensure that we have an information architecture that makes sense across the organisation. But I think it's fair to say that we have quite a good relationship in terms that we kind of discuss what we think is right, and he discusses, and then he links them up. So it's not. So before we had a kind of like a push-down system, whereas now I think it's more peer-to-peer, and Guy works more as the governor of that peer-to-peer system. If that makes sense.
Okay, great. That's good. Have we got any more, or is lunch pressing? Okay. No problem at all. Yeah, we can always delay lunch.
This is just a confirmation, really, then. So you didn't follow CQRS in this design because the two parts of the system are kind of welded in the same design. You're not separated out the querying from the updating.
Well, correct-ish. We have reader-writers, and so those reader-writers read and write entities. But typically what we're interested in is a separate reader which understands more the entire graph structure of it. So in that way, kind of like the public read is separated to a degree. But obviously if the models start changing, then it can impact on things. And I think that's the one thing we've got to try and figure out is we've got the system now, and how do you manage the next stage and next phase of change as that goes through? How do you detect when you start changing models, and what happens if someone else wants to put an extra bit of data into that model, and can you do it in a way that doesn't affect you? And mostly we think we're okay with that, but it's yet to be proven.
Okay, thanks.
No problem. Okay, well, Dan's going to join us for the panel session later on, I believe. Yeah, so more chances to quiz him. So I hope you've enjoyed the morning. And